Dear IoT openers, welcome to the lecture on analytics, aiming to introduce some general concepts about data processing and analytics. Data analytics is the process of examining data sets in order to discover, interpret, and communicate meaningful patterns, drawing conclusions about the information they contain, increasingly with the aid of specialized systems and software. Data analytics technologies and techniques are widely used in both academic research and business commercial context to gain valuable insights from an observed process, enabling organizations to make more informed business decisions and scientists and researchers to verify or disprove scientific models, theories, and hypotheses. Data analytics range from basic business intelligence to reporting and online analytical processing, OLAP, until various forms of more or less advanced and complex analytics. Data analytics methodologies can be characterized as exploratory, when aimed at finding patterns and relationships in data, and confirmatory, when applying statistical techniques to determine whether hypotheses about datasets are true or false. Orthogonally, they can also be categorized as quantitative, involving analysis of numerical data with quantifiable variables that can be compared or measured statistically, and qualitative, focusing on understanding the content of non-numerical data like text, images, audio, and video, including common phrases, themes, and points of view. Big data analytics apply data text mining and machine learning tools to sets of big data that often contains unstructured and semi-structured data for the goals above discussed. More specifically, based on such goals, four types of analytics operation can be identified: descriptive analytics, answering the question "what happened?", diagnostic analytics, answering the question of why something happened, predictive analytics, answering the question of what is likely to happen, and prescriptive analytics, answering the question of what action to take. Descriptive analytics does precisely what the name implies. They describe or summarize raw data and make it something interpretable by humans. They describe the past, allowing to learn from past behaviors and understand how they might influence future outcomes. The vast majority of statistics used to fall into these categories, basic arithmetic like sum, average, percent changes. Usually, the underlying data is a count or aggregate of a filtered column of data to which basic math is applied. Common examples of descriptive analytics are reports that provide historical insights regarding the company's production, financial operations, sales, finance, inventory, and customers. Diagnostic analytics help you answer the question of why something happened. Queries and drill downs enable you to request more detail related to a report, which can help explain surprising values through data mining and correlation. Diagnostic analytics take a deeper look at data to attempt to understand the causes of events and behaviors, better if coupled with, but even without, descriptive analytics. The function of diagnostic analytics, indeed, can be summarized into three categories: identify anomalies, by which, based on the results of descriptive analysis, analysts must identify areas that require further study because they raise questions that cannot be answered simply by looking at the data. Drill into the analytics discovery, in which analysts must identify the data sources that will help them explain these anomalies. Determine correlation and causal relationship used by analysts to uncover hidden relationship by looking at events that might have resulted in the identified anomalies, exploiting probability theory and statistics, regression analysis, filtering, and time series data analytics. Predictive analytics has its roots in the ability to predict what might happen. These analytics are about understanding the future. Predictive analytics provides actionable insights based on data to estimate the likelihood of a future outcome. This statistic tries to take the available data and fill in the missing data with the best guesses. They combine historical data and logs to identify patterns in the data and apply statistical models and algorithms to capture relationships between various datasets. Predictive analytics is the domain of data scientists who are tasked with the following 5 steps. Identify business outcomes or determine what questions need to be answered using predictive analytics. This also implies to identify drivers, independent variables that will most likely impact the outcome, dependent variable. Determine data required to train, since predictive analytics require data from multiple sources, and it's important to identify current data sources. If existing sources are insufficient, they must acquire data from other sources to ensure that models can be accurately trained. Determine the types of analysis, since different techniques such as neural networks, machine learning and data mining are suitable to answer different questions depending on the amount and the type of data available. Validate results, because of advanced analytics cannot be used as black box, but training data incorrect algorithms and poor assumption are just some of the pitfalls that can result in false prediction. This prediction on performance, since predictive models need to be continuously tuned to improve accuracy. Prescriptive analytics take the inputs from prediction to support the decision-making process. Prescriptive analytics is therefore suitable for situations where constraints are precise, for example in tactical choices, where many decisions need to be made within a given period, such as stock trading and fraud detection. Prescriptive model can be very complex to implement. Appropriate analytic techniques need to be applied to ensure that all possible outcomes are considered to prevent misstep. This includes the application of optimization and other analytic techniques in conjunction with the rules management. The function that prescriptive analytic tools provide falls broadly into 3 categories. Build a business case, since prescriptive analytics is best used when data-driven decision-making can improve several input variables or data volumes are high. A business case will help identify whether machine-generated recommendations are appropriate and trustworthy. Define rules, as prescriptive analytics required rules to be codified and can be applied to generate recommendations. Rules are decisions that are programmatically implemented in the software. The system receives and analyzes data, then prescribes the next best courses of actions based on predetermined parameters. Test, since the intent of prescriptive analytics is to automate the decision-making process. Testing the models to ensure that they are providing meaningful recommendations is mandatory to prevent costly mistakes.